Hello students. In this class, I'll be teaching you the binomial distribution and normal distribution. So let us start with the binomial distribution. A random experiment with only two possible outcomes, such as success and failure, is called a binomial trial, where the probability of success is denoted by P, and it has to be same for each trial, and probability of failure is denoted by Q, and Q is nothing but 1 minus P. Say for example, if you toss a coin twice, then the sample space will be HH, HT, TH and TT. In this case, getting a head is a success. So I denote P is equal to half and Q is also equal to half. And in each trial, the probability should be almost the same. So that is called as a Bernoulli trial. So in this case, the probabilities corresponding to these results will be, since getting a head is a success, this will be PP and this will be PQ, as getting a tail is a failure, that is, so it is Q. So this is PP, PQ, and this will be QP, and this will be QQ. Now, when you add all these probabilities, you will get this as P square plus PQ plus QP plus Q square, and this is nothing but P plus Q the whole square. So we can expand P plus Q the whole square. You will get the probabilities corresponding to this random experiment, and this can be obtained from the binomial expansion. Now if I say, for example, if I take for n trials, here there were only the two coins were tossed, that is, so n will be equal to 2. Here the process can be continued for n trials and obtain a binomials, that is P plus Q the whole to the power n, that is equal to NC0 P to the power n plus NC1 P power n minus 1 Q. Here the power of P reduces and power of Q keeps on increasing, and you have the coefficients of these to be NC0, NC1 and so on. And you already know how to evaluate these values, NC0, NC1, NC2 and so on. That is NCR is given by n factorial by n minus r factorial into r factorial. So a random variable x is said to follow binomial distribution if it assumes only non-negative values, and its probability function is given by, this is the probability function for a binomial distribution, that is given as NCX P to the power x Q to the power n minus x, where x running from 0 to n and Q is nothing but 1 minus P, and for any other cases the answer will be equal to 0. So x can take the value only from 0 to n. So the probability distribution is of this form: x comma P of x, where x is from 0 to 0, 1, 2 up till n. This is given by this tabular column. So you write x in the first row and P of x, which is given by this function. So for 0 it is, you substitute x is equal to 0, you just get Q to the power n, because NC0 is equal to 1. Next, for 1, you substitute x is equal to 1, you get NC1 P Q to the power n minus 1. For 2, NC2 P square Q power n minus 2 and so on. For n, it is just P to the power n, as Q power n minus n is nothing but 1 and NCN is also equal to 1. So this distribution is called the binomial or the Bernoulli distribution. So also we can see that every P is greater than 0, and when you take the sum of this Px, so when you take all these sum, that is nothing but Q plus P whole to the power n, and Q plus P will always be equal to 1. Therefore, since these two conditions are satisfied, that is P of x is greater than 0 and summation P of x is equal to 1, this is a probability distribution function. That is the definition of probability distribution function. So for any variable x to satisfy the binomial distribution, it has to take the values this. For P of x has to take the values NCX P to the power x Q to the power n minus x, where P is the success and Q is the failure. So for this probability distribution, binomial distribution, we have we can calculate mean is equal to, mean I denoted by mu, that is equal to NP, and standard deviation is given as root NPQ, and variance is nothing but standard deviation square, that is equal to NPQ. Now let us look at the problems here. A coin is tossed 5 times. So what is the probability of obtaining 4 or more heads? So P is probability of getting a head, that is equal to half. Q is also probability of getting a tail, so that is equal to half. Now the coin is tossed 5 times. So N is equal to 5 in this case. So probability of getting X heads in 5 throws is given as P of X, that is equal to NCX P power X Q to the power N minus X. Now you substitute what is N, P and Q. So we get this as 5CX into 1 by 2 whole to the power X, 1 by 2 whole to the power 5 minus X. So since the bases are the same here, you can add the powers. So this will be 5CX 1 by 2 whole to the power 5. So now probability of getting 4 or more heads is nothing but probability of X greater than or equal to 4. So X greater than or equal to 4 can be written as P of X is equal to 4 plus P of X is equal to 5, because there is only 5 trials and not more than that. So X can take the maximum value of 5. So therefore, P of X is equal to 4 is given as 5C4 1 by 2 whole to the power 5. That is 5C4 is nothing but 5. 5 into 1 by 32 is 5 by 32. Similarly, for P of X is equal to 5, evaluate the same way. You will get it as 1 by 32. Therefore, P of X greater than or equal to 4 is equal to add these two. So 5 by 32 plus 1 by 32, that is 6 by 32, which is equal to 3 by 16. So this is how you do the problem. Similarly, you can do the second one. It's for yourself to do it. Now 10 coins are tossed simultaneously. Find the probability of getting at least 7 heads. So N is equal to 10. Same P is equal to half. Q is also equal to half. You need to find the probability of getting at least 7 heads. At least means 7 or more. The minimum is at least is minimum is 7. So 7 or more you should get. So P of X greater than or equal to 7. So X greater than or equal to 7 means P of X is equal to 7 plus P of X is equal to 8 plus P of X is equal to 9 plus P of X is equal to 10. So that is how you evaluate the second problem. Now let us look at the third one. The probability that a pen manufactured by a factory be defective is 1 by 20. If 24 such pens are manufactured, what is the probability that exactly 4 are defective? At least 4 are defective, none of them are defective. So here probability, the random variable is finding a defective pen. So probability of a defective pen is P, that is equal to 1 by 20, that is 0.05. Probability of a non-defective pen, that is Q. Q is nothing but 1 minus P, that is equal to 0.95. Since N is equal to 24, we have P of X is equal to NCX P power X Q power N minus X. So exactly 4 are defective means P of X is equal to 4. Substitute, you don't have to simplify because these are all very big numbers. When you have a very small numbers only, you evaluate it or else keep it as it is. Now P of at least 4 are defective. At least 4 means minimum is 4. So 4 and more. Remember what is at least and at most. At least is minimum is 4. So that means 4 or more. When I say at most 4 means maximum is 4, 4 and less. So P of X greater than or equal to 4 is nothing but 1 minus these values. P of X is equal to 0, X is equal to 1, X is equal to 2, X is equal to 3. The probability of no defectives is this one. So that means probability of X is equal to 0. Next, fourth problem. Find the probability that in a family of 4 children, there will be at least one boy, second one at least one boy and at least one girl. Assume that the probability of male birth is half. So probability of male birth is assumed to be success. So P is equal to 1 by 2. Then for Q is equal to 1 minus P, that is equal to half. Here N is equal to 4 because it's a family of 4 children. So n is equal to 4. So probability function is given as p of x is equal to ncx into p power x q to the power n minus x. So substituting n, p and q, you will get this p of x. Now at least one boy. So at least one boy means 1 minus p of no boy. The how to analyze this is you consider this as say a dash. Probability of a is equal to 1 minus probability of a dash. One is the negation of the other. So probability of a is equal to 1 minus probability of a dash, where a dash is nothing but the negation of a. So same concept we'll use here also. So this is equal to 1 minus p of negation of a. Negation of a means a is at least one boy. So negation of at least one boy is no boy. So that will be 1 minus probability of no boys. So that is nothing but probability of x greater than or equal to 1 is equal to 1 minus probability of x is equal to 0. So substitute x is equal to 0, you will get this answer. So second one, probability of at least one boy and at least one girl. So when it is at least one boy and at least one girl, take the negation and write it as 1 minus probability of a dash. So negation of this will be no boy or no girl. So this will be 1 minus probability of no boy minus probability of no girl. This is equal to substitute and you will get this answer. Now let us look at the next problem. If 20% of the bolts produced by a machine are defective, determine the probability that out of 4 bolts chosen at random, 1 bolt is defective, 0 is defective, less than 2 bolts are defective. So probability of a defective bolt is 20%. So 20% is nothing but 0.2. So probability of a non-defective bolt is 1 minus p, that is nothing but 0.8. Now we consider at random variable xp, the number of defective bolts. We need to first find out that 1 bolt is defective, that is nothing but p of x is equal to 1. 0 bolts defective, so p of x is equal to 0. Substitute in this formula ncx p to the power x q to the power n minus x, you will get the answer. So we need to find the third one is less than 2 bolts defective. So less than 2 bolts is probability x less than 2. So x less than 2 is nothing but probability of x is equal to 0 plus probability of x is equal to 1. So you add these two, you will get the answer. This is all for the binomial distribution. Next, we'll go for the normal distribution. So random variable x is said to have a normal distribution with parameters mu, and mu is nothing but mean, and sigma square is the variance. So if its density function for this distribution is given by, this is the density function. So that means is suppose you have the values xi's and fi's, and if you plot the graph, after plotting you can fit a graph for that. So that graph function is nothing but this one. I will show you how the normal distribution looks. Wait. Yeah, this is how the normal distribution looks. About, say you will have x and f here. You will plot for every x corresponding to f, you will plot, and you will get some function here, and you can fit a normal distribution curve corresponding to the function which I showed you, and that will be the normal distribution curve. So let us look at some problems based on that. This is a very important topic, normal distribution. Obtain the function of the normal probability curve that may be fitted to the following data. So xi is given, fi is given. You need to fit the best normal probability curve. So to obtain a normal probability curve, you need sigma and mu. So for this xi and fi, you need to find out what is mu and sigma. That is nothing but mean and standard deviation. So you know when you have xi's and fi's, the formula for mean is summation xi fi divided by summation fi. Since we have already done all these things in the statistics, you can you know how to do mean as well as a standard deviation. Standard deviation formula is root of summation fi into xi minus x bar the whole square divided by summation fi. You can use it, either use this one or standard deviation by assumed mean method. Any one formula you can use and solve standard deviation. So after substituting summation fi xi minus x bar the whole square, that you add all these things, you will get 96 pi. Summation fi is 41. So you will get sigma square is equal to 2.341 or sigma is equal to 1.53. Now you're substituting sigma and mu in the equation, you will get this. So for this values of xi and fi, the best fitting normal probability curve is this. So f of x is equal to 1 by 1.53 into root 2 pi e to the power minus x minus a to the whole square divided by 4.68. Similarly, you can do this problem also. You need to obtain a normal probability curve that will be fitted to the following data. So xi and fi is given. Same way, you find out what is mean using this formula, summation xi fi by summation fi, and find out what is xi minus x bar the whole square fi into xi minus x bar the whole square for standard deviation. Substitute and simplify, you will get the best probability fitting, best normal probability fitting curve. Thank you.